Good day, class. Welcome to his physics variance. Today we are talking about the probability distribution series. Under that, we have Poisson distribution. Poisson distribution is used when there is a large number of trials and probability of success is very, very low. That is why Poisson is just like the advance of binomial distribution. Where binomial distribution cannot work, Poisson distribution can work because when there is a large number of trials and probability of success occurring is small, Poisson distribution is the best to be used. And let me show you the parameters of Poisson distribution. So we have parameters there. Parameters of Poisson distribution. Poisson distribution, just like the binomial distribution, also have the parameters. What are the parameters? Lambda, which stands for the mean. A, which stands for the sample size. Or better to use for Poisson distribution, let's call it the number of trials / number of trials. And B, which stands for success. These are the three major parameters of Poisson distribution. And the properties of Poisson distribution are, these are the properties of Poisson distribution. Number one, the mean is equals to lambda. These are the properties of Poisson distribution. Number two, the variance equals to lambda also. And number three, the standard deviation S equals to square root of lambda. These are the three major properties of Poisson distribution. Now let's solve the examples so we can understand better. General formula for solving Poisson distribution. P of S is lambda S times exponent minus lambda all over X factorial, where lambda equals to the mean and the formula for the mean is number of trials times success. The formula for lambda, number of trials times your success. This is the general formula for solving any Poisson distribution formula, any Poisson distribution problem. So let's try this example we have here. The example says 0.2% of the costs produced by a machine when it comes to the effective. Find the probability that 5 out of 1,000 costs will be effective. A and B, at least 2 will be effective. So what do we have? We have our A. What is our A? 5 out of 1,000, number of trials. Our A is 1,000 costs. For other persons. A is 1,000. Now the third one, probability that 5. So for wait, 0.2% out of the cost, meaning our P, our success is what? 0.2%, which is converting it to decimals, 0.2 over 100. If one is not here, you get 2 times carries from minus 3. So these are P. Now, option A, it says you find the probability that 5 out of 1,000 comes to be effective, meaning when X equals to 5, let's set our formula. So the P of X equals to what? Lambda X times exponent minus lambda all over X factorial. Meaning P of 5 now equals to, we have our N, we have our P, but we have our lambda. And what this is the formula for lambda? N times P. So meaning our lambda now equals to N times P, which is 1,000 times 2 times 10 raised to the power minus 1, which is equals to 2. This is our lambda. So P of 5 now equals to, because we say when x is 5 out of 1 that comes. When x is 5 now equals to lambda, which is 2, which for x equals 5 times exponent of minus lambda, which is what? Minus 2 all over x factorial, which is 5 factorial. So this is 2 raised to 5 all over exponent 2 times 5 factorial. Because if this minus 2 comes down, it's going to just 2. If you point it on the calculator now, you get 2 raised to 5 all over 0.036. So if you have probability, that's 5 out of what logs will be effective. That's the number of B. They say, what's the probability that at least 2 will be effective? At least and at most the difference. So we talk on at most. Now at least meaning the minimum was is 2. But at least 2 will be effective. Meaning from 2 and above. Meaning from 2, 3, 4, 5 to infinity. And we're not start doing that. Probability of 2 to infinity. We will not finish. So we have a formula to make to solve for at least 2. The formula for probability of at least 2 is probability of S 2 equals to 1 minus probability of X less than 2. This is probability of X greater than 2 because at least 2 means X greater than 2. So the formula is 1 minus probability of X less than 2. Now, probability of X less than 2 now, meaning we'll do for probability of 0 and probability of 1. Because 0 and 1, that's less than 2. So do the probability of 0 first, and we'll add it to the probability of 1. Now, probability of 0 equals to, from our formula, lambda is what? 2 x power x is what? 0 times exponent x power minus lambda, which is minus 2 all over 0 by 4. The point of the what we get is 0.135. Now, probability of 1. Because we said probability of less than 2 is we do probability of 1 and probability of 0 probability of 1 because that is only 0 and 1 that is less than 2. So my block was 0 because 0.135 and I said for 1 goes 2, which is the formula lambda is 2. This for x is 1 now times exponent minus 2 all over 1 factorial. The point is to get 0.271. So now probability of x less than 2 now is what? Probability of 0 plus probability of 1, which is 0.185 plus 0.271 equals to 0.406. This is the probability of x less than 2. So put this in our formula now. Probability of at least 2, which is x greater than 2, equals to 1 minus probability of x less than 2. So 1 minus 0.406, 0.594. So this is the probability of at least 2 will be effective. What I said earlier, it cannot solve probability of at least 2 because you do for 3, 4, 5 because at least 2 meaning 2 should be the least. 2 and above. You do for 3, 4, 5 to infinity and you will not end. So then the formula for solving for at least Formula is 1 minus the probability of less than the number they gave. You get to at least 5. You have the 1 minus the probability of x less than 5. Now you solve for x less than 5, which is 0 to 4. For yes, less than 2, so it's 0 to 1. So it's 0 and 1, but less than 2. You solve for it, this is our formula. Add them together, you get the probability of x less than 2. That could get your final answer, which is what I'm looking for. It's 1 minus probability of x less than 2, which is 1 minus 0.406. That is 0.594. This is our final answer. Then let's go back to the last distribution series, which is the hypergeometric distribution.